In the series of ninth class science NCRT, we have today the next video 1.2 characteristics of particles of matter. Under that we have 1.2.1. We'll do 1.2.1 in this video. And the heading of that is particles of matter have space between them. So everything is made of particles inside, some particles, and they have space between them. In activities 1.1 and 1.2, we saw that particles of sugar, salt, Dettol, or potassium permanganate got evenly distributed in water. Similarly, when we make tea, coffee, or lemonade, nimbu pani in Hindi, particles of one type of matter get into the spaces between particles of the other. Right? This shows that there is enough space. Wonder between particles of matter. Have you ever thought that? The level doesn't rise, it goes into the space. That opens your mind, right? That is completion of 1.2.1. Now we have under 1.2.1 introduction. We have 1.2.2. 1.2.2. Particles of matter are continuously moving. How do we know that? Inside. Activity. Put an unlit incense stick. Incense. That lovely smell you get. Stick in a corner of your class. How close do you have to go near it so as to get its smell? Is it a good question? Some incense stick is unlit. It's unlit. Now light the incense stick. What happens? Do you get the smell sitting at a distance? Record your observations. It's a simple directing of your attention onto a particular fact in nature, that there is an incense stick in the corner. It is burning, right? Or not burning. When it's not burning, you don't feel the smell. When it's burning, you get the smell from a distance. Okay, I think it's clear what he's trying to say. Movement of particles. Moving. Activity. Activity 1.4, second activity. This overall in the chapter is activity 1.4. Take two glasses or beakers filled with water. Right? Put a drop of blue or red ink slowly and carefully along the sides of the first beaker, and honey in the same way in the second beaker. Drop of blue or red ink at the sides. Two glasses you take. Honey in one, slightly you have to pour, and drop of blue. Leave them undisturbed in your house or in a corner of the class. Record your observations. What do you observe immediately after adding the ink drop? What do you observe immediately after adding a drop of honey? How many hours or days does it take for the color of ink to spread evenly throughout the water? How many hours or days does it take? Record your observations, he is saying. Activity 1.5. Drop a crystal of copper sulfate or potassium permanganate into a glass of hot water, and another containing cold water. Do not stir the solution. Allow the crystals to settle at the bottom. What do you observe just above the solid crystal in the glass? What happens as time passes? What does this suggest about the particles of solid and liquid? Does the rate of mixing change with temperature? The rate of mixing, like spread, change with temperature. You get me? If you raise the temperature, does the mixing rate of mixing, how fast it is spreading become and a change? Why and how? From the above three activities, 1.3, 1.4, and 1.5, we can conclude the following. What can we conclude? Particles of matter are continuously moving. That is, they possess what we call the kinetic energy. Here, he is introducing words. One thing we have to do in science is we have to open the doors and wait. And when you reach the end, actually your eyes will open. It will be very radical. You'll rise above the average way of learning by rote and come into the great field of open science. Scientist will become. Particles of matter are continuously moving. That is, they possess what we call a kinetic energy. As the temperature rises, particles move faster. So we can say that with the increase in temperature, the kinetic energy of the particle also increases. In the above three activities, we observe that particles of matter intermix on their own with each other. That's the whole point. They intermix on their own with each other. They do so by getting into the spaces between the particles. This intermixing of particles of two different types. See, this might seem like ordinary thing in real life, but actually it's wonder. Of two different types of matter on their own, intermixing on their own of two different particles, two different substances is called diffusion. We also observe that on heating, diffusion becomes faster. Why does this happen? Why does diffusion become faster? Why does this happen? He leaves it at that. So we know we got the idea now. So this idea which is here is that particles of particles of matter, particles of matter, which is this is also particles of matter. Here also the particles are moving inside in solid or liquid. They are moving inside. We don't see that, but we can guess that indirectly by such things. Actually, why should if two things mix? Why should they mix? That is a wonder question here. Why should they mix in the first place? They are mixing because they're moving inside and they're getting into each other's spaces. So there are spaces between particles, and there are particles. First, we proved just with ordinary experiments that there are particles. Then we proved that there are spaces between particles. And now we prove that they're continuously moving. Next, we'll prove that particles of matter attract each other. Attract each other. And then we go to the states of matter. Solid. Why is the solid? Solid. Why is the liquid? Liquid. This is the wonder. Why is the gas? Gas. And here I would like to pause and share that all that we see around is actually a miracle going on. This is sound, light is coming, blue sky. It's not really blue. This is what happened to me when I was 33. It was delayed for me. I should have understood in the school itself that there are fundamental and basic questions. In fact, ironically and very sadly and tragically, I would say, whole world doesn't yet know science. They have not done this. It is so pathetic, isn't it? Think about it.